All right, so as I just mentioned, you did have tangent in Chapter 8, and then something slightly different, but is still technically related to what we're going to be doing here. That relationship can be difficult to see, but hopefully we can work through that as we go. The definition of tangent: a line segment, or ray. It could be any of those. Remember, a line means it keeps going in both directions. A line segment means it stops. And a ray means it keeps going in one direction. That intersects the circle in exactly one point, or at exactly one point. And you have to make sure that no points of that line segment, or ray, lie on the inside of the circle. So you might want to paraphrase that as some people just say it's a line that hits the circle once on the outside, something like that. It's fine, because this is not one of the definitions I will ask you to necessarily, give to me verbatim. And then once you have that definition down, see if you can answer that next question. It says, which of the following are examples, or which of the following is an example of segment AB being a tangent line segment? Okay. Again, it's got to hit only once, and none of the points can go in the circle. So on the smartboard, we can kind of refer to them as green, blue, and red as far as the segments, but on your paper, obviously, you can't see that. Or we could refer to it as number 1, 2, and 3, either way. Do you believe 1 would be considered a tangent based on the definition? 1 being this one here with the green line segment AB, the first one. Is that tangent? Does it hit the circle just once? Yes, I would say it hits the circle once, approximately right there. And do any of these hit anywhere inside the circle? No. Now, obviously, this is a segment, or it could be a ray, or it could be a line, but it still works out the same way. It's nothing really different. How about the second one? So this one, we're saying yes to this one. You don't have to put your answer inside the circle. That was just where I chose to put it. Yes, that one is a tangent. How about the second one? No. Well, for one, it hits the circle twice, and some of the points are inside the circle. So that's a big no. That actually has another name, which we will learn later. And how about that last one there? Is it okay if it stops right where it hits? Yeah, sure. Why not? So yes. Okay. And those points where it actually did hit just that one time is called, let me make sure it's not somewhere later. Is called the point of tangency. Okay. That's what it's called. I mean, they were very clever with that. It's what made it tangent, and so they said it's the point of tangency. Very clever. So does this middle one have a point of tangency? No, it's not tangent. This one over here does. Yeah, it's actually point B on this one. Over there, it's that point that I made in green on that first one. Okay. So any question what a tangent's going to look like? I don't understand the question.
Line segment go inside the circle?
No. Line segment cannot go inside the circle at all to be a tangent. That's called something else. Okay, okay, important note. If a tangent is connected to the center of the circle by a segment, then the segment is perpendicular to the tangent at the point of tangency. That's a lot of words. Let's break it down. If a tangent is connected to the center of the circle by a segment. So over there in the picture, we have segment AB, correct? Do we agree that AB is a tangent? Is it connected to the center by another segment? Which segment connects it to the center? CD, right? CD is right there. Do you agree CD is connecting that at the point of tangency? Because D is the point of tangency, right? So does that follow what we just talked about in this important note? It does. So what's that perpendicular word mean? It means it forms a right angle. Very good. Guaranteed right there, boom. But it has to come from the center. And didn't we have something else that was pretty much the same thing, right? With the chords and everything, it had to work out that way. So that's kind of nice. That's going to be important. And of course, CD in this particular instance could be called the what? Radius, correct? Now, does this say that it cuts that segment in half or anything like that? No, because it doesn't have to. It could, but it doesn't have to. So as you see here, AB is a tangent, CD is a radius. We talked about that. So AB is, remember that symbol right there is perpendicular to CD. Oh, that's in the picture. The point of tangency is D. Well, any questions on that? That was pretty straightforward, huh? I think we can do that. Whoa, big picture. All right, determine X. It's telling you that segment AB is tangent to circle C. So that's also telling you that the center of the circle is C. So that's important. So in other words, CB here is the radius, correct? So we were told that AB up here is a tangent. We are connecting it to the center. So angle B up there in that triangle must be a right angle. Yeah. Because again, this could extend if you feel, well, maybe extend yours a little better than that if you're going to do it, but that would be a right angle. Okay. Now, I put the blue arrow on there because X is the entire, it's from A to C is X. I want the whole thing. And so, how are we going to go about that? Pythagorean theorem sounds like a really good idea. Because if you look at the red triangle there, it's a right triangle. We know SOHCAHTOA works. We know Pythagorean theorem works. If we really wanted law of sines to work, it would, but we don't need law of sines. We don't need to find an angle. We need to find a side. So which one, 5, 7, or X? Which one's the hypotenuse? X. So it'd be 5 squared plus 7 squared, because unfortunately 5, 7 something is not a triple. Well, it is. It's just not a nice one. 5, 7, and X. So far, agreed? So 25 plus 49 equals X squared. And the best part of algebra here is just to add those two numbers together. And so what do we get there? 74 equals X squared. You take a square root. And X is approximately, and technically it'd be positive or negative because of the algebra, right? And boy, what is that? It's a little less than 9, and it's a little more than 8. 8.6, if we round to the tenths, right? But now let's talk about the negative part of this answer. This would be the answer if we just did algebra. But does negative 8.6 make sense for the length from A to C? No, negative doesn't. Not make sense at all. 8.6 is that distance. And we'll answer this question right here. What was the point of tangency in the previous example? B, very good. And I'm just, out of curiosity, I'm just going to ask you something else, see if you can do it. Who can tell me the distance from there to there? Sound effects, again, optional when you do it. He says 3.6. Does that look like 3.6? How is it 3.6? How do you know that? Yeah, isn't this also a radius right there? So wouldn't that also be 5? And if the whole thing's 8.6, would that have to be 3.6 out here to make it 8.6 total? Very good, perfect. Well, sometimes pictures are hard to draw and to get them to be accurate, so. Although a smartboard does make that a lot easier, it gives you a lot more freedom when drawing. It's much better than trying to do it in Word. Still good? Ooh, change the question around on. He says, determine whether RT is tangent to circle S. I forgot the dot, apparently. There you go. So S is the center. Our job is to figure out if it is tangent. For it to be tangent, what should we look for? It means it better hit at a right angle. If that hits at a right angle, I think we're good. Well, how do you check that? Well, you say, well, let's assume it's a right angle, and if it is, Pythagorean theorem better work, correct? So if we're going to draw the triangle separately over here, we know this one would have to be 12, this one is 16, and my hypotenuse is how long then? How'd you get 20? It says 8. Oh, that's right, the radius is 12, and so this whole thing would be 20. Oh, I gotcha. All right. So while I save this, why don't you go ahead and figure out if that is tangent or not.